Chapter 3, Making a Filter. In this chapter, I will be attempting to clearly explain how the hex filtration chart is built. First, let's take a good look at the example chart that I've been referencing throughout this book. Do you remember how in Chapter 1 I pointed out the patterns that seem to flow from left to right on every row? It may look crazy, but it's actually a simple, consistent, repeating set of the same 6 hexadecimal digits. In fact, in Chapter 2, we worked with these digits in every column. We used them to search for the prime number digits contained in each one, so to speak. If you don't remember exactly what those digits were, here you go. They are 6, 7, B, D, E, and F. Now, if you've been paying good attention to the hex chart, and I hope that you have been comparing the pattern from each row to the others, you might have noticed that each of these digits seem to separate from each other as you compare the pattern from earlier rows with the pattern of later rows. For example, row 2 shows the pattern 7, B, D, E, and F, whereas row 8 shows the pattern 7, F, 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 B, F, 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 D, F, 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 and E, F, F, F. Can you see how both row 2 and row 8 share the same basic pattern using the basic 7, B, D, E, and F? I can see how some might miss this, but if you ignore the large amount of the hex F's, then the pattern is the same. I'll explain this more clearly here in a moment, so just hold on to that for now. If any of you have happened to notice this fact already, then I want to say you're right on track. Good job for paying attention. In which case, I hope you observant fellows also noticed that all of the odd-numbered rows seem to follow a slightly different pattern. The pattern you might have noticed for the odd rows is 7, E, D, B, and F. Well, do any of you see the difference? If not, that's okay. I'll tell you. Try to pay attention to the B and E in each row. I believe you should notice this change now. If you look real close to each of the rows, the even rows always have the B preceding the D and E, whereas the odd rows always have the E preceding the D and B. This is important to note because it comes into play here in a second. First, let me explain why there are so many F's. As I explained in Chapter 2, every hex column effectively represents 4 digits in binary. If those digits are a 1 and stay a 1 for every specific associated binary digit placed in that column, then the base 10 number that it correlates to is a prime number. Well, as it so happens, the hex F digit is made up of 4 binary digits. This means that every time you see a hex F digit on the hex chart, it just means that every associated base 10 number for that column could be prime, as far as it's concerned. Of course, you still need to check all of the hex digits in the column, obviously. However, back to the point. You probably noticed by now that every row, both odd and even, has an ever-increasing amount of these hex F digits. This means that the larger the row number gets, the more your chance of finding prime numbers increases, at least as far as the row is concerned, that is. It might seem unmanageable to have to deal with so many F's, but I assure you that even this problem has a nice little pattern to it. Remember how the non-F digits always stay the same for every row, when you ignore all of the F's, respective to their odd and even row numbers. Well, interestingly enough, the hex F digits progressively increase by 1 for each group of F digits found in any given row pattern. With this information, you can make a simple chart to represent this behavior. Please look at chart number 2A. I hope you managed to easily understand that chart. Let's call it the F's chart for the moment, just to be fun. If you had any trouble reading it, then I'm happy to explain. First, let's take a look at the top of it. You should see 8 hex digits, each in a specific column of their own. I'm sure you will recognize how these digits seem to be set in the same order that is followed by every even row of the hex chart from before. If you trace down through each column for these digits, then you will notice something interesting. Only the columns marked with a hexadecimal F digit have a number set that increases as you go. The 7, B, D, and E are always marked with a 1 digit. Why? Well, all these numbers listed represent the quantity of hex digits for any given row. This is extremely useful to know, and if you've paid attention to what I explained earlier in this chapter, you will see that the F digits increase along with the rows as they continue to progress on into infinity. This same concept also applies for the odd number rows as well. Please look at chart number 2A again. If you are interested to know, the H at the bottom of each F column in chart number 2A is used to represent a math formula that can be used to determine the number with regard to each row in a given F column. It works like this. H equals row number times 2 plus 1, all divided by 4. And always drop the fraction. Next, look at the bottom of each column one last time to check and see if the H variable has a negative 1 with it. If it does, simply reduce the number that you got by 1 and place it on the row that you calculated it for. This is for those geniuses who want to calculate for that really big row number, but don't want to count the amount from 0 with the F's chart because that could simply take too long. So, how can we put this to good use? Good question. Now that we know how the pattern progresses for both the odd and even rows, we can finally determine how to correctly place the digit patterns onto the hex filtration chart. Okay then, so where do we begin? Well, technically, if you really wanted to, you could choose any row number you want to start at. However, remember that determining primes requires that the previous rows are filled in as well. Otherwise, you won't have a complete data set, and this could cause headaches for anyone who tries to read it when it's incomplete. So, to avoid having to try and fill in a lot of row spaces by hand, I suggest that we start at a relatively low number. I normally prefer to start at row number 0 and build up from there, but I can understand the enterprising soul who wants to start high and work down. I think for now it would be beneficial to build from row 6 because this gives plenty of room to go up and down the chart with pattern. Plus, this allows you to use the example chart number 1A as a reference. First, we have to determine which column the pattern starts in for row 6, and no, I don't mean go look it up in the example chart I just mentioned. We'll use the formula row number times 2 plus 1 squared. This gives us the initial base 10 number represented by the starting column's hex digits. Remember from Chapter 1 that each column represents 4 base 10 numbers, and the first number for that group can be used to determine its column value. Okay, let's do this. We are starting with row 6, so let's put it into the formula I just gave you. 6 times 2 plus 1 squared equals 169. Well, there we go. We have the first base 10 number. Let's use it to calculate the column number value. I think I should leave this one up to you. If you need to go back to Chapter 1, it's okay, I'll wait. I sure do hope you made the attempt to figure it out on your own. If not, then I don't blame you. So, did anyone get a 21? Good for you! Now you know that the pattern for row 6 starts at column 21, and you can finally start filling everything into its place on the hex chart. Let's use chart number 2A to determine which pattern we will follow. I chose this because we know that row 6 is an even number and the chart is built for even numbered hex chart row patterns. I suppose it shouldn't be too hard from here. Simply place one hex digit from the pattern on our little chart number 2A into each new column of the hex chart in the order that is listed. Try not to forget that some rows have more than one, or sometimes even 0 hex F digits in its sequence. So be sure to pay attention to the numbers in each of those F columns. If you filled in the entire pattern from chart number 2A, you don't have to stop at that point. The pattern will simply repeat itself on and on into infinity and beyond. If you want to repeat the pattern Go ahead, it's your hex chart. Make it as long as you want, though I caution you, you might want to consider all the other rows you still have to fill in. Just saying. There, that's pretty much it. However, I still have a little that still needs to be explained about row 0 and row 1, though not right here. It will be more clearly explained in the next chapter, so please try to hold on a little more. This whole thing is about done. Now go in and fill the rest of those rows. Everybody is waiting on you. Example flowchart for row number 6. Create your basic chart with numbered rows and columns, like chart 1A. Determine the starting column for row 6, i.e. 6 times 2 plus 1 raised to the power of 2 minus 1 divided by 8. In this case, it's 21. Look at chart number 2A and find row number 6. Input the pattern listed on chart 2A into your blank chart, starting at column 21, row 6, i.e. 7 F F B F F D F F E F F F. This pattern goes from column 21 to column 33 and repeats forever.